In this video, you are going to learn about reaction stoichiometry. What is stoichiometry? Stoichiometry is the relationship between the relative quantities of substances that taking part in a reaction or forming a compound. In other words, stoichiometry is about the calculation of how much the reactant is needed or how much the product will be produced. Let's look at this balanced equation. Let's look at the coefficient. In front of N, there's nothing. That means it is 1. In front of the hydrogen, it is 3. So over here is 1, 3, and 2. What do I mean over here? That means for every single 1 mole of nitrogen, we need 3 moles of hydrogen, and we will produce 2 moles of ammonia. The coefficient here, it is the ratio of moles, not about the gram. For example, can I say I have 1 gram of nitrogen react with 3 grams of hydrogen and give me 2 grams of ammonia? No, you cannot say that. It is about moles or number of molecules. It is not about grams. Okay, let's look at the other one. Let's look at this one. How many moles of iodine are required to react with 0.429 moles of aluminum according to the following balanced equation? Okay, so let's see what the question gave us. How many moles of iodine? Okay, so we are looking for this one. How many moles? This part, aluminum, is already given. It is 0.429 mole. Now, remember, the coefficient in the equation is the ratio of moles. So now, if I start with 0.429 moles of aluminum, how many iodines do I need? If I have 2 moles, I need 3 moles of iodine. So what we're going to do is, I'm going to write it again, 0.429 moles of aluminum, moles of Al, and each 2 moles of aluminum, I need 3 moles of I2. Okay, in the future, you do not need to write down all this like of iodine or of aluminum. Okay, so the first time I'm going to write everything down so we can look at it and make it clear. Okay, so I can cancel out this one. So what I have is 0.429 times 3 and then divided by 2. What I will get is 0.429 times 3 divided by 2. I get 0.644, about 0.644 mole. Okay, let's review and see what we have done. What is given is a balanced equation, and what is given is the number in moles of aluminum, and now we are looking for how much of iodine is needed. We are very lucky that it's already given in moles because the ratio is in moles. Okay, so the next step is we look for the ratio. It is 3 to 2, so we have to multiply by 3 and divide it by 2. So this is what we get, 0.644 moles. Okay, it may be easy. It sounds easy. Let's look at the next one. What mass of sodium hydroxide would be required to produce 16 grams of magnesium hydroxide by the following balanced equation? Okay, so what we are looking for is we want to produce 16 grams of this molecule, magnesium hydroxide. Now remember, all the coefficient over here, it is about the ratio of moles, not grams. So if you have grams, make sure you have to convert it into moles. So how do we convert it? Well, we need the molecular mass. Okay, so how do we do that? Let's go to the periodic table and look for the atomic mass of each. So Mg, I went to the periodic table. It is 24.31, and the unit can be AMU or grams per mole. Okay, so oxygen is 16.00, and hydrogen is 1.01. How do we get the molecular weight or molecular mass? It will be 24.31 over here plus 16.00 plus 1.01, and then because there's a 2 over here, so we multiply by 2. Let's see what we get. So we have 24.31 plus 16.00 plus 1.01, and then multiply by 2. So the molecular weight for magnesium hydroxide, it is 58.33. The unit will be the same as here, grams per mole. Okay, so 16 grams will be equivalent to how many moles? So 16 gram, we need to cancel out the gram, so we should put the gram in the bottom, and we want to convert it into moles. So gram will be 58.33. So what I would get will be 16 divided by that number. I get 0.274 mole. 0.274 mole. Aha! So we find out how many moles of this will be equivalent to 16 grams. Okay, so let's look back at the equation over here. What we are looking for is we want to know how much of sodium hydroxide is needed. Pay attention at the coefficient here. It's 2 to 1. That means if we want to produce 1 mole, not 1 gram, 1 mole of magnesium hydroxide, we will need 2 moles of the sodium hydroxide here. So therefore, how much do we need? We just have to double it. So it will be 0.274 multiplied by 2. So that's what we need. And that is equal to 0.548. That many moles of sodium hydroxide. Okay, so now we know how to get to the moles. But the question asked, what mass? Oh my God, they asked too much. Okay, so let's convert this into mass. How do we get the mass? Well, we find the formula weight first. Sodium hydroxide. Sodium, I went to the periodic table. So sodium, Na, what I get is 22.99. The unit will be grams per mole. And oxygen, we have it over here, 16. And hydrogen is 1.01. So sodium hydroxide, it will be 22.99 plus 16.00 plus 1.01. And that is going to give me 22.99 plus 16.00 plus 1.01. That is equal to roughly 40.00. 40.00. Again, the unit will be grams per mole. Okay, so I know the molecular weight or formula weight. So what is in grams if I have 0.48 moles? So we just have to multiply this number by 40.00 gram per mole. So the mole can cancel out. What I will have is 21.92. 21.92 grams. Okay, let's review, see what we have done. From the previous example over here, what happened is the question gave us how many moles, okay, and asked to calculate how many moles. In this case, it's very simple. We just have to look for the ratio. However, when the question is given instead of moles, but it is given in grams, we have to convert the grams into moles first. If that is the case, we need to calculate the molecular mass or the formula mass. That's why we did this one. We calculated the molecular mass for the magnesium hydroxide and also for the sodium hydroxide. The reason to calculate that is we need that to calculate for how many moles, because in the balanced equation, the coefficient is the indication of the mole ratio. Okay, so we convert it into moles, find out how many moles, and at the end, we convert it back into grams. All right, let's look at an example. Over here, let's look at problem number 14 over here. Problem number 14. I2, the iodine, is produced by the reaction of 0.4325 moles of copper chloride according to the following equation. Okay, so now we know the number of copper chloride. It's good that it's already in moles. So that many moles. So let me write it down. Is 0.4235 moles. Okay. So the first part of the question is how many moles of molecule? Well, how many molecule? Let's say how many moles of molecule, okay, of iodine here. So let's look at the ratio. It is 2 to 1. That means I'm looking for iodine. It will be 0.4235 times 1 divided by 2. Okay. So what I will have is 0.2117 for 8 if you round it off. That many moles. Okay. The next one is, what is the mass? That means how many grams. How do we do that? Now we know how many moles. So we need the molecular mass. For iodine, I went to the periodic table. What I find out is 126.90 moles, grams per mole. That is the atomic weight. So for the molecular weight, I have to multiply that by 2. Why? Because there are 2 atoms in a molecule. So I have 126.9 multiplied by 2. What I get is 253.8. 253.8 grams per mole. And how many moles do I have? I have 12118. So I multiply them together, I get 53.75 grams. Okay, let's review what we have done. First of all, we have looked at the equation and we determined the mole ratio. Very luckily, the question already gave us how many moles. So from the ratio, we determined how many moles of the iodine product we will have. And that is this part over here. If we know how many moles, can we convert it into how many grams? Yes, we just need the molecular mass. Okay, so when we multiply the number of moles by the molecular mass, what we get is the mass.